Hey friends, my name is C, and today we'll look into 5.3 for adding and substituting volumes for the questions video for the Edexcel A-level further maths core Peer 1 module. And we'll first look into this question right here, and these questions are from exercise 5C from the textbook, so you can check it out. So here's the first question, or the fourth question on the exercise. The shape shown is bounded by the curve y equals a half x squared, and the lines 2x plus y equals 6 and 2x minus y equals minus 6. Part A. Find the coordinates of the points A and B. So we know these two are the coordinates of A and B, and we can see that the coordinates of A lies within the line 2x minus y equals minus 6, and we know that the x value is minus 2, and the x value for B is 2. So we can basically just plug it into this equation to find the corresponding y value, right? So for part A, we know that for we can rearrange this equation to get for the point A, and we know that it's equal to y equals 2x plus 6, right? So when x equals minus 2, we can just sub it in, minus 2, negative 2. So minus 2 times 2 is minus 4, minus 4 plus 6 is 2, so it's just 2, right? And we can notice that they both lie on the same horizontal level, so therefore the y value for A is 2, and also the y value for B is 2. So therefore, the coordinates of A is minus 2, 2, and the coordinates of B is 2, 2, like so. And part B, the shape is rotated around about the y-axis to generate a solid revolution. Find the volume of the solid generated. So first, we can just ignore this part right here. We'll just focus in whatever's in the first quadrant. So we can see that we can split this shape into two different shapes. We can split it into part A, or shape A, and shape B, right? And for shape B, we have to use volumes of revolution to rotate around the y-axis. But for shape A, we can notice that if we were to rotate around about the y-axis by 360 degrees, we can see that it's a cone, right? So we can use the cone formula where it's basically V equals a third pi r squared h. Pi r squared h, where this is the radius, the r, and this is a h. And we know that this point right here is 2, therefore the height of the cone is 4, right? So let's just do it step by step. So part B, the volume for A, is a cone, so it's a third, 1 over 3, pi r squared h. Pi just remains as pi. R squared, r is basically 2 because this is r, which is 2. So pi 2 squared. H is 6 minus 2, right? The difference, this is the height. 6 minus 2 is 4, so the height is 4. And we can now simplify it. So it's basically a third times pi times r 2 squared times 4, which gets us 16 over 3 pi. So it's all like 16 pi over 3, 16 pi over 3, like so. That's the first part. For the volume for B, we'll just use integration. So it's basically equal to pi times the integral of x squared. Because we have to rotate around the y-axis, so we have to make x the subject. So x squared is equal to 2y if we were to rearrange it. So dy, 2y dy, right? And the bounds are from y equals 0 to y equals 2. So 0, 2. So this equal to pi times y squared from 0 to 2. And this gets us 4 pi for the volume. So therefore the total volume, V total, is equal to VA plus VB, which is equal to 16 pi over 3 plus 4 pi, and this gets us 28 pi over 3. 28 pi over 3, and the units is in, there's no unit, so it's just unit cube. So unit cube, and that's the answer. Oops, let me just use a new color. So 28 pi over 3, unit cube. 28 pi over 3, unit cube. And the next question, the shaded region is bounded by the curve with equation y equals 4 minus x squared, and the curve with equation y equals the cube root of x, the y-axis, and the line with equation x equals 1. the region is rotated through 360 degrees around about the x-axis. Find the exact volume of the solid generated. So we know that it's rotated around the x-axis, so it rotates this way right here. So we can also split it into two different areas. So area 1 is our area A and area B, where B is basically the area, the volume, not area, the volume under this curve right here, from x equals 0 to x equals 1. But for area A, we'll consider the whole volume, not area A, it's volume A, the whole volume under this curve right here from x equals 0 to x equals 1. So to find the shaded region, the volume of the shaded region, we just have to do the volume of A, which is the whole thing, minus the volume of B, which is this small thing, which takes away this part, and it leaves us with this part right here, which is what we need to find, right? So let's just find the volume A first. So volume A is equal to volume A is equal to pi times the integral of y squared. So y is 4 minus x squared, so it's basically 4 minus x squared squared. So 4 minus x squared dx from x equals 0 to x equals 1 dx, yep. So expand it gets us pi times integral of 16 minus 8x squared plus x power 4 dx, which is equal to pi times 16x, 16x minus 8 over 3 x cubed plus a fifth x to the power 5 from x equals 0 to x equals 1. And if you were to sub in the bounds or the limits, we know that it's equal to 16 times 1 minus 8 over 3 times 1 cubed plus 1 over 5 times 1 to the power 5. And if we have to subtract when we substitute x equals 0, but it's basically 0 anyway, so just ignore this case right here. So this gets us 203 over 15, everything times by pi, like so. 203, yep, 203. Let me just write it properly. So 203 over 15 pi, like so. So now we have to find a volume B, which is basically the volume under this curve right here. So volume B is equal to pi times the integral of y squared. So y in this case is x to the power of a third. So therefore y squared is x to the power of 2 over 3. Right? X to the power of 2 over 3. dx from x equals 0 to x equals 1. Like so. So let's just integrate it. So it would be pi times 2 over 3. Integrate x to the power 2 over 3. You know that 2 over 3 plus 1 is just 5 over 3. So just flip it around. So it would be 3 over 5. 3 over 5. X to the power 5 over 3. Right? Times the bounds are 0 and 1. So substituting it gets us 3 over 5 times basically 1. And minus 3 over 5 times 0. And that gets us 3 over 5 pi. Like so. So therefore the volume of the shaded region, will be equal to the volume of A minus volume of B, right? So volume A minus volume B, which is 203 over 15 pi minus 3 over 5 pi, and that gets us an answer of, let me just put in my calculator, that gets us with 194 pi over 15. So 194 pi over 15 unit cube, like so. And the last question, the diagram shows the region R bounded by the curve with equation y equals x squared plus 1 and the curve with equation x squared plus y squared equals 11. Part A, find the x coordinates of the points of intersection of the two curves. So we just have to first substitute this y value, like this value right here, into here to solve for x value. So part A, so we know that the second equation is x squared plus y squared equals 11. So it'll be x squared, it'll be x squared plus y in this, from the first equation is x squared plus 1. So it'll be x squared plus 1 squared equals 11. Simplifying it, here's this x squared plus x power 4 plus 2x squared plus 1 equals 11. And simplify further, x power 4 plus 3x squared minus 10 equals 0, right? And we can perhaps simplify this by just what we can do is that we can either just set x squared equals a constant and just factorize from there, or we can just factorize straight away if we know how to factorize. And this factorizes to x squared plus 5 plus 5 and x squared minus 2. Oops, and x squared minus 2 equals 0, right? So this gets us with x squared equals minus 5 and x squared equals 2, right? But if you were to solve x squared equals minus 5, you get a non-real root, right? So it doesn't. So we'll just ignore this, and we'll take this case where x equals plus or minus root 2. Therefore, we know that this point right here must be when x equals minus 2, and this point right here must be x equals 2, right? Sorry, x equals root 2. So therefore, we know the coordinates of the points of intersection where x equals plus or minus root 2, which is basically this right here. And I write in a new color so it's easier to see them. So x equals plus or minus root 2, like so. And the last part, the region R is rotated 360 degrees around about the x-axis. Find the volume of the solid generated, giving your answers correct to the 2 decimal place. So we'll just find this volume here, this part right here, half of R. So it's basically the volume under the first curve, this curve right here, and then minus the volume under this curve right here. So we'll just call this curve curve 1 and call this curve curve 2. So the volume under curve 1, so volume under curve 1 is equal to we know that it's rotated around x-axis, so we just set y as the subject, or perhaps y squared. So it will be equal to pi times the integral of y squared, which is 11 minus x squared dx from x equals 0 to x equals root 2, right? Root 2 dx. And this just basically integrated, you get pi times 11x minus a third x cubed from x equals 0 to x equals root 2, 0 to root 2 and 0, and basically just put into a calculator. So 11 times root 2 minus a third times root 2 to the power of 3, and that gets us 31 root 2 over 3 times by pi. So 31 root 2 over 3 times by pi is number 1. So the volume under curve 2 will be equal to y squared is basically x squared plus 1 squared, which is basically pi times x power 4 plus 2x squared plus 1, because it's basically x squared plus 1 squared, which is what we have over here. So it'll be x to the power 4 plus 2x squared plus 1, like so. And step a dx from x equals 0 to x equals root 2 as well. Root 2, right? So now we just integrate it. It'll be pi times a fifth x to the power 5 plus 2 over 3 x cubed, 2 over 3 x cubed plus x from x equals 0 to x equals root 2. So just substituting into a calculator, you get 1 over 5 root 2 to the power 5 plus 2 over 3 times root 2 squared, root 2 to the power 3 plus root 2, and that gets us 4.431 times by pi, and you get 13.92. 13.92, or just put into more decimal place, 13.921, right? So now once we've got both volumes, we know that to find the volume for this half region of R right here, we need to do the volume of this curve right here, the x squared plus y squared equals 11 curve, which is the volume for 1. This curve, the volume for this, minus the volume under this, the second curve right here, the volume under this one right here, right? So we have to do volume 1 minus volume 2. So let me just do it right here. So volume 1 minus volume 2 will get us half of R, which is equal to, let me just put it into my calculator. So volume 1 is 31 root 2 over 3 pi, minus volume 2, which is 13.921, and that gets us 31.989. 31.989. So therefore the volume of R is just double of that. So the volume of R, let me just put it into my calculator in a different color. The volume of R is basically 31.989 times by 2, which gets us 63.98 unit cube. Because we're not given any other units, so we just have to use unit as our unit. And that's the final answer. And that's it for this video for 5.3 for adding and subtracting volumes for the questions video. And if you need any learning resources or any teaching slides, you can check out my website in the description. And if you found it useful and helpful, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And in our next video, we'll look into 5.4 for modeling with volumes of revolution, which will be fun as you'll relate volumes of revolution to real life scenarios. But anyway, that's it for this video, and I'll see you all in the next video. Until then, stay safe and happy learning.